Okay, so we're at the site of the LTER discharge gauging station on the Bonner River. Not quite sure how to say that. This is a tributary of the Piscu stream, which is where our camp is based, just down valley there. And it flows out of this particular stream flows out of the Solas Glacier, which is further upstream. We can't quite see it, it's just around the corner. And so this project here, in the box there will be a data logger and batteries, and you can see there's a solar panel on the side there, which is also providing some input. A line then is going down to a pressure transducer in the river there, which is recording stage. Now it's quite difficult to measure discharge directly, so what we generally do for a river such as this is measure the stage, and a pressure transducer essentially converts the water pressure, the head of pressure, into a stage or a depth, which is then used to estimate discharge. In order to do that with any kind of confidence, what we need to do is confine the flow such that the stage has a nice correlation with the discharge. We don't want the water to be completely spread out across the floodplain in estimating discharge. We want it to be confined at a particular point. So site selection is very important, but also, and as you can see, in this case, a sort of a weir type construction has been built, which means that the water is all flowing through that one particular point and is confined at that location, meaning that you're going to have a nice correlation between stage and discharge. In order to get that correlation, you need to construct what's called a rating curve, which is essentially a graph with a curve going through points representing the stage and discharge being estimated using the cross-sectional area of the flow and the speed of the water flow. Combine those two things and you get the discharge, the volumetric discharge, or the number of litres per second or cubic metres per second flowing. In this case, it's not very much. So that's, in a nutshell, the principles of stream gauge measurement in a system like this. It's like I say, it's pretty difficult, and these data are available to download.
Can you tell us, Matt, what the long-term ecological, I forget what the R stands for. Research is. So the point of these stations is to collect long-term, multi-decadal measurements.
Yeah, throughout the dry valleys there's been quite an extensive network of hydrological monitoring performed by Diane McKnight and colleagues as part of the long-term ecological research program. And the ecology, of course, is largely dependent on water, so hydrology becomes an absolutely critical component of looking at how ecological systems function. So as part of their research, they've shown that there's a lot of diversity of microbial life within the dry valleys, which is totally dependent on the water variations. And so streams such as this only flow for between 4 and 10 weeks per year, and the rest of the time they are frozen, and the water is almost exclusively from glacial melt. You don't have any rainfall. You do get snowfall, a little bit of snowfall, but most of that sublimates, meaning it turns directly to vapor, doesn't really contribute to stream flow at all. So all of this is dependent on glacial meltwater, and that glacial meltwater is dependent on the things like the temperature, the ambient air temperature, but also primarily the solar incidence, the amount of solar radiation that the glaciers are getting. So you have quite a strong control on stream flow as a result of the sun. Now, at this time of year we have 24 hours of sunlight, but the sun is shifting around in the sky. So one of the controls of the solar incidence and the amount of solar radiation a glacier is getting is the slope that the glacier is sitting on and the amount of topographic shading that it gets from mountains surrounding. So the primary glacier that we are looking at, the Croix Glacier, gets topographic shading in the middle of the night, essentially, around about between 2 in the morning and something like 4 or 5 in the morning. There's topographic shading within the lower valley, and I expect the lower parts of the glacier as well. So that'll be having an influence on the amount of meltwater coming off into the stream. And a similar sort of situation will be occurring in Ninnis, the Bonaire stream.
Cool. Done.